Sorry.
Great. Hello, Aditya. You mind introducing yourself before you begin?
Yeah, let's do it. So my name is Aditya. I'm a first-year computer science major here at Georgia Tech. I'm from Connecticut, and I've been interested in cybersecurity from a really young age. So I'm really excited to share this story that I find pretty interesting. So first of all, who knows what Mega is, the company? Very good. Yeah, cloud storage provider based out of New Zealand. They're open source. They have 200 million users, and I think they give you 20 gigabytes in the free account, right? Did it change? I think what differentiates Mega from Google Drive and like OneDrive is the fact that they use end-to-end encryption and they're fully open source, which I'll talk more about on the next slide. Yeah, I already opened it so if you don't know what Mega is, it's essentially like Google Drive. It's another cloud storage service that you can use. There we go. Yeah, I mean, that's essentially what it is in a nutshell. It restarts you when I go back. Yeah, so a little about end-to-end encryption / zero-knowledge encryption. They both essentially mean the same thing. The key is that it's not the same thing as HTTPS or SSL. That's what we call transport layer security. End-to-end encryption deals with data that's already stored on the server, not what's in transport. So I have this nice graphic on the next slide that essentially explains it. This is what encryption at rest, this is what your Google Drive, your OneDrive, your Dropbox, this is what they do. So you have your decrypted information, it goes to the server and gets encrypted with their encryption key. The key difference you need to see is the encryption key is on the server. So essentially the encrypted data and the encryption key are in the same place. The company has access to the encryption key. By contrast, end-to-end encryption, everything is encrypted on the client side with the encryption key. The client has the encryption key, so the only thing being sent to the server is what's encrypted of your files. You have your encryption key, and in a lot of end-to-end encrypted systems, the encryption key is going to be based on your password. It's not exactly your password, but they'll get it from your password. And the thing you need to understand is, if you lose your password, you basically have lost all your information on like an end-to-end encrypted system. Like on Google Drive, if you lose your password, they have the reset your password option, but you don't get that on end-to-end encrypted services like Mega because they have no way of decrypting your information unless you give your password. Does that make sense? Any question? So what happened? 2022, researchers at ETH Zurich, which by the way, I don't know what ETH stands for, but it is one of the best universities in all of Europe. Researchers there found something pretty interesting, and I'm going to use someone as an example. Who wants to be the example? Nash, yes, sir. So let's say Nash is just using Mega on a daily basis, all right? What we found is if I watch Nash log in 512 times, I have enough information to recreate his encryption key. I'm gonna let that sink in there. If I watch Nash log in 512 times, I have enough information to recreate his encryption key. Yes, sir.
So what's the purpose of recreating an encryption key when you can just look at the password and then like log into their account?
Good question. So the password is not the encryption key. It's like a hash function that'll help you get the encryption key from the password, but you can't work backwards, and that's the thing.
What do you mean by watch someone log in? And you intercept all their network traffic?
Good question. There's two ways I can watch you log in. One is to do a man-in-the-middle attack on you. So I give you a fake login site that literally looks real. You put in your password, and the metadata generated there helps me get some information. The other way I can watch you log in is if I literally compromise your browser or your laptop. So those two ways, if I can see the metadata being generated whenever he logs in, that's what I'm looking for. Yes, sir.
Okay, so to be clear, like you say, metadata that's generated from when he logs in as opposed to like his password itself.
Correct. We're not getting the actual password here. We're getting metadata that's generated because remember, we don't know how Mega gets their encryption keys from the password. So we can't really do much with the password except for like go directly to his website. But yeah, Nash, like he follows all the security protocols that he should be doing. Good password, don't share it. But if I can watch him log in through a man-in-the-middle attack or literally by compromising his browser, using that metadata, I can recreate his encryption key. And this has a couple implications. If I can recreate his encryption key from all this information. Yeah, so obviously when I get his encryption key, what's the next thing I can do? I can take everything from his account, decrypt it, and look at all the files he has. That's what plain text recovery is. They have what they call a framing attack, where I can put a file into his account using the encryption key that I got. I can put a file into his account that Nash didn't put in there, you can already see what the implications of this are for like a business. Integrity attack, it's similar in some ways. The biggest difference is with integrity attack, I'm gonna change the files he already has on his account. I might delete some of them, I might change them. And yeah, I mean, and the last one is pretty important because if Mega markets themselves as a end-to-end encrypted service, but the researchers just figure out how to create your encryption key, is it really end-to-end encrypted anymore? Yes, sir.
So if you compromise someone's browser, aren't you getting all their data anyway? Is there a situation in which you could get access to the data, but you wouldn't be able to access like the person's password or like, the other information?
Yeah, so the place where they actually found this metadata was on the network traffic between your browser and the server. That's actually where they found this information. Your password and your username, that stuff would be encrypted with HTTPS, but using metadata from that network traffic, they were able to find that you could get your encryption key from there. If you
Like
watch
timing
the,
information, what sort of metadata was that? What
I
sort of-
gotta go back and read the paper a little bit more, but this was on the front page of Mega's news, and that's where I got it from. I thought the most interesting part was 512 times. That's how many times I've watched you. I can recreate it. Yeah, so what was Mega's response to all this? Number one, they acknowledged the work of the researchers, always good because security researchers do a lot of work. But the thing is that they found no evidence that this actually impacted someone, which, yeah, 512 times. I'm not trying to sit there and watch that. But yeah, they deployed a patch. Now, you'd think that they'd change their encryption algorithm because the reason they had this problem is because they were using an outdated RSA algorithm. You would think they changed the encryption algorithm, but no. Instead, they deploy a patch to purge the metadata. There's actually a button in Mega, if you know it, you can purge the metadata from all your past logins. That's what they deployed. They did not change the encryption algorithm, and here's why. If you change the encryption algorithm, now everyone has to reset their password. New encryption key, new password from everyone. You can already see the bad PR they're gonna get. Everyone's gonna be worried. Everyone's gonna think it was compromised. So for that reason, they decided not to make everyone change their password. We're gonna do something a little different. That makes sense? Yes, sir.
Do they use a cipher block at all?
Oh, could you repeat that?
Do they ever use a cipher block for like, also including like an encryption key? Do you know what like a CBC cipher block is?
I don't.
Oh, okay, never mind then, that's.
You can explain it if you want.
Yeah, so I noticed that one of the one of the attacks that they use is a padding oracle attack. And from what I learned, a padding oracle attack could occur for CBC, a cipher block mode, I believe, where basically the problem with hashing is that a same input always leads to the same output, right? So then how they had it will be like, I believe there's one CBC block, like one cipher mode they use is CBC where like they have take the previous ciphertext. This is for decryption, by the way. For like decryption, they take the previous ciphertext and then XOR it with a D block, and D block is gotten from a decryption algorithm, and they XOR with that to create some sort of plain text. So I was wondering if Mega uses like cipher blocks. Maybe that's why they didn't change it.
Algorithm. So I don't know what their exact decryption algorithm is, but it is, the code base is open source, so you can go and look up what it is. I haven't put the time to actually look at what it is. Yeah, someone else had a question, I think. Yeah, so does this all make sense why they responded the way they did? Yes, sir.
Do you know why exactly it was 512 times? Because the RSA keys are usually like 124 bits or
256 bits usually.
Yeah.
Yeah, so why was it 512? I mean, the number makes sense because it always goes in multiple powers of 2. Yeah, but most encryption keys are 256 bits now, and why was it 512? I think it has something to do with the fact that encryption keys are just 256 bits, but the paper that was released, and it's at the end of this slideshow, if you want to look at that, that probably can give you more information on it. Yes, sir.
Do they like reuse keys maybe perhaps? Like encryption algorithm requires like a random key and then detect. So like do you think they're like reusing the keys somehow?
That's why we're able to look at it 512 times.
I mean, I assume because like RSA, I mean, the problem for RSA is that it's expensive and that's why not a lot of people use it, which is a bit surprising that Mega is using RSA to begin with. But yeah, I assume the possibility is they could like be reusing the keys, some of the keys, and since you're logging in 512 times, they could like, I mean, are they is that attacker comparing it from like others as well? Like, do you know if they're like
Yeah,
comparing?
previous login sessions from
Oh,
you.
yeah, so then that could be a
Yeah.
possibility, I know.
That's possible, yeah. I mean, it was an outdated algorithm, that's what they said. Okay. So what were the key takeaways? In this case, an end-to-end encrypted system, we did have a vulnerability in it, but that doesn't mean that end-to-end encryption is bad by any means. You need to understand that end-to-end encryption for storage applications like this, it's a little bit different from like if you're using email or chatting, that's where you have your public-private key system. In this case, end-to-end encryption, you have the encryption key. Yeah, and encryption algorithms can have vulnerabilities too. They're actually working to fix that. I think AES 256-bit is the newest one, right? Or the one that they all use, I think. That's the one that all the big tech ones use. So RSA is a little bit older, that's why it had a vulnerability, but yeah. Any questions? And these are all the sources I used. Any questions? Yes, sir.
Does Mega provide the option to use a different encryption algorithm?
No, they set that and you can't change that. Because if they did change their encryption algorithm, that means all the users have to change their passwords. Anyone else?
All right, well, thank you.
Yep, thank you.